Welcome to the channel. I hope you're all having a wonderful day. Today we'll be looking at Tushar's birthday party. And for this problem, well, it's Tushar's birthday and he throws a party for his friends. And what we're given is the eating capacities of each friend, the filling capacity of each dish, and cost of each dish. A friend is satisfied if the sum of the filling capacity of dishes he ate is equal to his capacity. I guess he only has guy friends. We find the minimum cost such that all of Tushar's friends are satisfied. And we have a couple of notes. Each dish is supposed to be eaten by only one person. Sharing is not allowed. Another note, each friend can take any dish unlimited number of times. And 3, there always exists a dish with filling capacity 1 so that a solution always exists. Okay, so now we see input format. List of integers denoting eating capacity of friends separated by space. We also have capacity, list of integers denoting filling capacity of each type of dish. And we have the cost, list of integers denoting cost of each type of dish. We're also given constraints where the capacity of friend, number of friends, and number of dishes all are between 1 and 1,000. So it's a little bit confusing, but this first column here, these 2's, they tell you how many elements are in that array. Can be confusing at first, but if we see that, then we see that the first row, there are 2 friends and their capacities are 4 and 6 respectively. So our solution output is 14. Let's take a look at why that might be. So it says the first friend will take first and second dish. So if they take the first and the second dish, that's the cost. The capacity that it fills is 1 plus 3, which is 4. So that means the first friend will be full. And we also see that if you take the first and the second dish, it's 5 and 3. It will be a cost of 8. So we see right here, 5 plus 3 for part of the cost. Then we see the second friend, it will take the second dish twice. And it goes back to the note, which is you could take any dish unlimited number of times. So yeah, the second dish costs 3 and the capacity is 3. So the second friend will be satisfied because their capacity 6 is reached. And their cost is 6, so let's see here. 3 times 2 is 6, and 14, which would be the minimum. And so the minimum 14 is the cost, and we want to minimize that. So this problem, if you have seen Knapsack before, it's very similar. If you haven't seen Knapsack, it's okay. You could still try to attempt this problem, but if you're stuck, maybe take a look at Knapsack. So this problem is really cool because we're given the constraint of the capacity. So what it means is that we can use DP, where the DP array will represent each index of the DP will represent, of our DP array will represent a capacity and the minimum cost to reach that capacity. And so if we compute that from 1 all the way to 1,000, then we will be able to find the minimum cost for any friend because all friends have their capacities between 1 and 1,000. So essentially we can boil this problem down to how to solve the knapsack problem. And so I'll show you a little example of what I mean here. The main idea is that we have our capacities bound by between 1 and 1,000. So to solve this problem, we can make a DP array, and it will have the elements between, well, this is the 0th indice, this is 1 indice, and all the way up to 1,000. And each ith indice represents minimum cost to reach that capacity. So each DP of I will be some combination of dishes to reach that capacity, and then the value will be the minimum cost of purchasing all of those dishes. So because we know all the friends will have dishes between 1 and 1,000, we can first break the problem down into calculate DP array between 1 and 1,000. 1000. And then 2, we we index the array and choose, for instance, we see ours, the first column right here, these 2s, they tell us that each row has 2 elements, and this first row is friend capacities. That's how much they need to eat to reach to be satisfied. And then the second is the cost of each dish. And lastly, the capacity of each dish. And then lastly is the cost of each dish. So we index the array, and for us, we see we have friends capacity of 4 and 6, so we would get dp of 4 and dp of 6. We would sum those values, and we would get our total minimum cost. And so now the question becomes, how do we populate the dp array? And so first thing we have to do is initialize dp array with all zeros, and 0 will indicate to us what capacity has not been initialized. And so whenever we see dp of I, that's one case. And when we see this case, we check if the capacity of dish equals the index. Because if the capacity of the dish equals the index, let's say capacity of dish equals 2 and index equals 2, then what it means is that we can eat that one dish and reach that capacity. So that means the cost would equal cost of whatever is in index 2 for capacity for cost of dish. Well, we would call it current cost because current cost of that dish, because the capacity of dish is 2, but it doesn't necessarily mean that it has to be an index 2. So the other case is when the capacity of dish does not equal the index, and in this case we have to check I minus capacity of the dish is greater than or equal to 0. And what this means is that, for instance, let's say the I equals 2 and capacity of the dish equals 1. It means that I'm looking at I minus capacity, which is 2 minus 1, and dp of 1 is the minimum cost to eat a dish of any, or eat any combination of dishes to reach 1 capacity. And if I eat this current dish, which has capacity of 1, then I will have capacity of 2. So it means dp of 2 equals dp of 2 minus 1 plus the current cost. Now the last case is when I have already filled the array for the certain capacity. And so in this case, I'm checking if there is a minimum, if the new dish can have a combination that is better. So dp of I equals the minimum. Maybe the previous combinations I already found the smallest, so we have to put dp of I, but it's also possible that the current dish can be better. So that's why I check if the current cost and see if adding the dish can make it better. So I do dp of I minus capacity. It's similar logic to this line here. Yeah, so this one's also this case. Yeah, so now we're try a small example to illustrate. I won't fill up to 6, it's kind of a big example, but let's try it up to 4. Yeah, let's try it up to 4. All right, so one other thing is that we will be iterating through each index of DP, so from 1 to 1000. And then in each iteration, we will iterate all capacities of dishes. And here, these things are what we do at each indice, on each iteration. And so the first thing is we have I equals 1, and then the capacity index is 1, or it's 0, which I'll put with a star. Yeah, and we check, first thing is we check if the dp of 1 is 0, and we see here it is 0, so now we're in this case, and we check if capacity of dish equals index, and so the capacity of dp of 0, capacity of dish Alright, so maybe I should, this will be a cap index. Yeah, so the cap index, if we see cap index 0, so in the 0th position we have a 1. So we see in this case that I index equals capacity of dish. And so what we're supposed to set is dp of I equal to the current cost. And yeah, you know what? It's better to just call this the current cost. So we'll change that. Right, so this is actually current capacity. So this is the current cap, and this is the current cost. Or I guess it should be called dish index. Yeah, so let's call this dish index. So we don't check the current cost equal to index, we check if the current capacity equals the index. And so yeah, this was just an example for current cap equals 2 and index equals 2, but now you guys understand what that means, so I'll delete it. And then dp of I will set it equal to the current cost of the dish, and the current cost is 5. Now we go to the, once that is done executing, we'll be done with that case. And so we then go to the next dish index, which is 1. And then we see that it has not been initialized. So we go to this case. And so there will be if here, and then will be if here. And this is the elif. And yeah, this is just an example. Dish index. No, it's current cap. So we subtract the current cap. Okay, and this is the case where we don't initialize, or we already have something initialized, and then we check if I minus the current cap greater than equal to 0. All right, so we're on dish index 1, we go here and we check I minus current cap, and right now I equals 1 and the current cap is 3. So 1 minus 3 is negative 2, and it's not greater than or equal to 0, and this is what this condition is supposed to check, if it goes out of bounds or not. So now we move on to I equals 2, and once we are in I equals 2, we go back to dish index 0, and we check capacity of 0, and that would be 1, and the cost would be 5. And so we see dp of 2, and it is 0. So let's see, this should initialize 0 should happen first. And then the next thing is to check if dp of I equals 0. All right, so now we have dp of 2 and equals 0, and we check if the current cap equals the index I, and it does not. So we go to the elif, and we do 1 minus the capacity, I minus the current cap, and that yields 1, so that means dp of 1, or dp of 2 will equal dp of what? 2 minus 1, which is dp of 1. So that dp of 2 equals dp of 2 minus 1. And we add the current cost, and the current cost is 5. So dp of 1 is 2. It's 5. We add that to 5, so now we have 10. And now we're done executing that. Now we're on dish index 1, and so the capacity of the dish is 3, and the cost is 3. So we see dp of 2 is 0, it's not, so we go here and we check I minus cap, and 2 minus 3, that's not greater than or equal to 0, so we go on to the next one. So now we're on I equals 3, and we go to dish index 0, and so we see it's 0 first for dp of 3. Let's change these to 1 and 5. And then, yeah, after we change those, we see it's 0, and the current cap does not equal to I. So we check the elif, and 3 minus 1 is dp of 2. So we have dp of 3 equals dp of 3 minus 1, which is dp of 2, and we add the current cost, which is 5. So 5 plus dp of 2, and that will give us 15. Now we move on to the next one, which is making the dish index 1, and the current capacity now goes to 3, and the cost of the dish is 3. So once we're here, we check if it's 0, and dp of I is not 0 because we just filled it, and then we do I minus current cap, so I is 3, current cap is also 3, so we check dp of 0, and that is 0. So now we have dp of 3 equals the minimum of dp of 3, or we do dp of 0, and we add the current cost, which is 3. So that's better, and so we update this to 3. And next we move on to our last in the small example, and then we have I equals 4, or yeah, that's correct. I equals 4, and then we go here, index 0, and then this one changes to 1, and this one changes to 5. And so we check, okay, dp of 4, it is 0, and then current cap is not equal to I. So we go to the elif, and then that's 4 minus 1, which is greater than or equal to 0. So we have dp of 4 equals dp 4 minus 1 plus the current cost. So it'll be 5 plus dp of 3, which is 8. And then we move on to the next dish index, which is 1, and this changes to 3, and this changes to 3, and then we know that the dp of 4 is now not 0. So we check this, I minus current cap. So then, yeah, that is greater than equal to 0, so dp of 4 equals minimum dp of 4, or dp of 4 minus 3 plus 3. So dp of 1, which is 5, if we add 3, we get 8. So we're getting the minimum of 8 and 8, and that is the same. And we see that in the example, 8 is the correct answer for 4, capacity of 4, because we eat one of the first dish. We know the capacity for the first friend is 4, so we eat one of the first dish, which is capacity of 1, and it also has capacity of 3 eating the second dish, so they're satisfied. And then if we do the cost of each dish, we have 5 plus 3, and that is the best combination. So yeah, hopefully you're able to understand the main idea and understand the run through for this algorithm. This video is running kind of long, so I'll make a second video to post the full code, but hopefully this is enough for you to get started and think about the problem and possibly try different ways to solve the problem. Yeah, hopefully you have fun and learned, and I'll see you guys in the next one.